the infinitely many solutions.
Oh, so I need to take out the
I'm going to pass around a stapler. So questions that you would like to go over, look at, talk about? Audrey.
I had it, 19.
19, the labor force problem, right? Yeah.
I did that.
All right, so number 19. From 1840 to 1990, the percent of labor force in farming and non-farming occupations can be modeled by the following equations. You have to remember, like, if we're talking about in the 1800s, I mean, most of the jobs that were created were based off of farming. It wasn't anything like it is today. Even in the 1990s, I mean, it was a lot different 30 years ago. So the equations that were created here were taken by actual data, and these would be line of regression. So taking data, creating the scatter plot, and then coming up with that best fit line. So these are two equations that would represent best fit lines. Not that you need to know that, but that's really how these equations were created. So the first one represents the farming occupations. Occupations. You can see this one's negative because it's going to decline. They're going to be the lower amount of farmers because land is being developed. Non-farming occupations increase because if you're losing farming jobs, then that means buildings are being created, economies are growing, and we don't rely on that as much anymore. So the question is, in what year was the labor force split equally into farming and non-farming occupations? And then it does say round to the nearest year. So the equations are given. You didn't have to come up with them, but we have to decide how to solve for them. And you can use substitution or elimination. I would say, I mean, they're both equally the same. I don't think one way is easier to do than the other in this case. Any suggestions about what to use or what you use to solve the problem, Chelsea?
I use substitution.
So if you use substitution, how do you use substitution here?
For the first equation, you just add 0.48 t to both sides.
Okay, so she said the first equation, you could add 0.48 t to both sides. So we have 0.48 t plus y equals 67.2. And then in the second equation, to use the substitution, what would you do?
You just keep it the same and then plug it in.
Yeah. So she said you would keep it the same and then plug this piece in for y. So she's making the first equation look like standard form so that you can then take the second equation and plug it in for y. So I'm keeping the 0.48 t. And then instead of this y, you're going to plug in 0.48 t plus the 32.9, and then that's equal to 67.2. So this is one way that you could solve the problem. So use substitution. So she added the 0.48 to get the x and the y together, or the t and the y together. And then replacing the y with the second equation, the 0.48 t plus 32.9. And then if you combine your values together, Chelsea, if we combine this together, we get
0.96.
0.96 t. And if you subtract 32.9, you end up having
34.3.
good, 34. And then if you divide by 0.96, it's going to be
35.7.
good. Because of the decimals, it's just a little less than dividing by 1. So then the question says, in what year was the labor force split equally? Round your answer to the nearest year. So if it wants us to round to the nearest year, this would be approximately 36 years. But what year is 36 years? So, Brandon?
1876.
Yeah, if we started in 1840, we're increasing that by approximately 36 years. So in about 1876, the farming versus non-farming types of occupations would be the same. You could have also used elimination for this. If you would have just added these two equations together, the t's cancel out because one's positive and one's negative. So you could have 2t equals 100.1, and then get y, but you still have to take y and plug it back in. So in this case, you're finding t, you don't have to then take t and plug it back in anywhere. But if you used elimination and eliminated the t from the problem, you get an answer in y equals form that you have to plug back in to get the time. Questions on that one? That was a good one. How about another question?
On 3.1, 17 through 20.
So 3.1, 17 through 20. So you didn't have to do the graphing problem. But you did need to do 17 in order to do 20. So 19 was not necessary, you didn't have to graph. But in order to answer 20, which was asking you to find the break-even point, you had to actually answer 17 as well. So an extra question kind of got snuck in there. So break-even, if something is a break-even analysis or a break-even point, what's that mean? So like if a company wants to break even, Isabella?
Yeah, maybe money or losing money.
Yeah, so when in terms of businesses, there is income, money that you bring into the company, then there are expenses. And if it needs to break even, we want our income and expenses to be the same. And that's where every company wants to be. Obviously, you want to make more than, your break-even point, but you don't want to be losing money. So this is a question kind of gauging like how many months would it take for the company to like be created so that they weren't making money but they weren't losing money. So R, it says, is representing revenue. Revenue is income. How are you earning money? So if we look at the revenue,
What's up, Grant?
how would we bring in money based off of the problem? So how could we bring in money, or how are you earning money in this problem? What's the revenue? Chelsea?
5,500.
Right, 5,500, it says, is the estimated monthly revenue. And that's for every month. And it said in the problem right here that the months are T. That's the only way that we're earning money. It's just whatever we're selling is going to earn us $5,500. Nothing else goes with that equation because that's the only information that talks about revenue. Number 18 says, write a equation to represent C, or cost. What does it cost you to have this company? So we're earning $5,500 a month, but what would the cost be to have the company? Dylan?
3,200 P plus 115,000.
Good. So it says that the monthly expenses are $3,200. An expense is part of a cost, but then you also have to pay for the music store, which is also part of your cost. So the amount that you have to pay to purchase it is that $115,000. So both of these pieces represent the cost. And then if we want to find out the, number 20 said, how many months will it take until the revenue costs are equal? You don't have to graph this. I think that graph is a horrible graph that's provided. So instead of actually graphing it, you can set them equal to each other because break even means when is the revenue and the cost the same. So if you take your 5,500 and set it equal to the cost equation, you can then find out how much time it will take. So if we subtract 32 here, we end up with 23. And then you're dividing by 2,300. So 115,000 divided by 2,300. What does that make? Nina? Yeah, Nina got 50. And that's in time. Apparently I can't spell the word months today. Yeah. So So how many months will it take for the revenue and the costs are equal? It'll take about 50 months. Questions? All right, so the stapler made it all the way around to Josh. So if you could make sure.
I didn't get the stapler either. I didn't get the stapler.
Well, somehow it made it all the way around. All right, so if you could pass that forward, if you have it stapled, make sure your name is at the top. Give me a smiley, a neutral, a frown.
Why did you come late to Miss Pauletti's class today?
Oh, sorry. Nope. Because it was like during every teacher had it.
Mine are gonna choke.
No, I didn't show my work.
What period were you doing?
It's fourth,
Yeah,
and then I think it's like first and.
Do we have?
I mean, my teachers can't come because it's connected to this first day period. Thomas is doing Thomas is doing
In your notes packet, if you'll turn to section 3.3, please.
Wait, do we need graph paper for our work?
Yeah.
Oh, should I get grab 2 papers then? Grab 2 graph papers?
There's 8 problems to graph. So.
Wait, how many problems?
Oh, yeah.
You know what you grabbed me now?
Man, you grab me another one.
You grab
Miss
it.
J,
Yes.
don't ask all the questions.
Okay.
That's despicable. I
I
can't
brought you guys some. Give some to Chelsea
You will, you hate
and Cooper. Chelsea, you said you needed graph paper.
So section 3.3 in your notes, please. You'll need the graph paper for homework. There's 8 problems you'll graph. If you have other graph paper somewhere else, feel free to cut off. If you have extra graphs that you didn't use in other homework assignments, you can always make your own axis if you don't have enough with you.
No.
We did it all the time.
I'm always prepared. I have that now.
Alright, so we're going to be doing systems of inequalities today instead of systems of equations. So when you have a system of equations, you graph your 2 lines, you look to see where they cross, where they intersect. With a system of inequalities,
I hate technology. It just doesn't. We have blackboards. So like I hate
so it's 2 or more inequalities that are graphed. On the same axis or on the same grid. I missed an E. Today we'll just be graphing 2. Tomorrow you'll look at graphing 3, 4. By Wednesday we'll grade graphing 6 on the same one.
That's so happy. That's a joke. I'm just kidding.
So a solution to a system of linear inequalities is what? So for graphing these inequalities, what's a solution to the inequality? Ian?
Or the intersection point.
That would be if it was equations.
I don't know.
Where the
Oh,
shading is?
shading.
Where the shading, wait, we'll break it down.
Where the shading, where the what?
Crosses, it overlaps.
Overlaps, right. Ladies and gentlemen, up here, please.
I saved the right.
So, as Brandon said, it's where the shading overlaps, or you could call that the overlapping region. Because it's like an area of the graph, a section of the graph. It might make a shape of a triangle or maybe a trapezoid, depending how many equations you're graphing. So it's not just a point, but now it's a whole section of the graph. So the overlapping region, the overlapping section, but wherever those areas, the shaded areas are intersecting or crossing. But now it's a whole area, not just a point. And then it says the graph of a system of a linear inequalities is just whatever region your graph exists in. Sometimes that ends up being like your whole graph ends up being shaded.
Hate inequalities.
Alright, so just a review. Today we're only doing 2. And a little bit of review with those how to graph them. The first thing you need to do is graph each inequality separately. You may want to use colored pencils to distinguish the different solutions, the different areas, whatever you want to call it, the different inequalities.
Are you using like to write a solution?
Yeah, I'm going to write solutions. So each line gets its own shaded colored pencil. Identify the region that is common to all the graphs or overlapping, but I think common fits best in here. This region is the graph of the system. You can use colored pencils, or if you use colored pencils, the graph of the system is the region that has been shaded with every color. So the solution should be where if you have 3 colors, then all 3 are overlapping. The first one is pretty straightforward and basic. You have 2 lines, they're already y by itself, so you don't have to get y by itself, but you might have to in your homework tonight. So it's just y is less than 2x plus 1, y is less than or equal to negative x plus 3. So graph each one separately. First one starts up at positive 1. And the slope is rise to right 1 or fall to left 1. So when you graph an inequality, you have to remember shading, but what else do you have to think about when you go to connect the points, Cooper?
If it's not equal to, then it's a dotted line.
Yeah, so if it doesn't say the equal to, less than or equal to, greater than or equal to, when you connect those points, you need to make a dotted line, dashed line, however you want to think
I
about it.
remember doing this in what's it called? Algebra.
Right.
I learned a lot until my teacher like had a baby, and then we had the worst subject in the entire world. I hated it so bad. And then my English teacher had a baby, and then the same sub that came with him
Oh
out.
my
I hated it.
How does that work?
And then
She was the worst teacher.
Oh my goodness. Alright, ladies and gentlemen up here, I promise I'll be here all year. Not going anywhere. Alright, so if it's less than, when you shade, I don't want you to think shading left or right or shading diagonally. Less than means below, greater than means above. Don't think any other way unless it's an exact vertical line. That's the only time you should be thinking left or right. So if I have less than, go to a point on the line, and again, don't shade left or right. Less than means below, underneath. So if I go to any point on the line, and I always just start with the y-intercept, but you need to go below that point or below the line. So don't tell me you're shading left or right. You're not. You're shading up or down.
With one
We're
of the
shading
colors.
with one of your colors. So in this case, we're shading below the dotted line because it said less than.
Oh shoot! I heard it.
So then your next line is negative x minus 3. So you're going down to negative 3. Your slope is negative, so down 1, right 1, or up 1, left 1. This one has the equal to, so Cooper said if it doesn't have the equal to, it's a dashed line. So since it has the equal to, it's our standard line that we would graph. And again, you're going below the line. So go to a point on your line and go underneath it or below that point. And then with your pen, pencil, whatever you're writing with, darken the area that's common to both. So don't leave your graph with both parts being intersected. You actually have to darken that region that's common to both. And it should be kind of a triangular section at the bottom.
Yeah. Do you have any Pilot G2 pens?
I do.
suggest buying them. They're so good.
That's what I usually grade with. They're my favorite.
Yeah, they're so good.
They're very smooth. The ink just flows.
Yeah. I think it's this little yellow thing right here. I don't know what that does, but it just I feel like that's so good.
Any questions about the graph?
I feel like that's not.
All right, so flip your page over. Graph this second set of inequalities that are up here. So the first inequality has the y by itself, but the second one you'll have to get the y by itself.
Okay, so we should walk around.
You got this.
Let's see, who knew the best.
It's the same slope. Below.
No, it isn't.
It's much there.
Nina, you guys be
Wait, what?
You should roll on the
Yeah. On the first one, you put
But if,
the
who
second
wants,
one.
oh man,
Oh, Nina.
man, Miss Kate, I messed it up.
Uh-oh. You need an eraser?
Good
Hey,
thing I haven't
the
erased
good
my
thing is-
pencil.
Same.
Oh my god, same.
I'm
Good
so
thing
happy.
Those are the color pencils we buy at our house, erasable ones.
I don't care. That's
Yeah,
it.
those are the nice.
Why aren't all
Sweet guys,
I don't know, I feel like they all should be that way.
the color pencils they
Miss
should
Kate,
have
I
erased.
just messed this one up bad.
You wanna try and erase it?
Here, you can try that.
Yeah, thank you so much. You're such a good friend.
Alright, so your first one, already y by itself. You don't have to worry about getting the y by itself. Solid line, because it's less than or equal to. You need to go underneath the line, so below the line. So less than or equal to, below, underneath. Again, get out of the thinking left or right, so below, above.
Wait, that's not right.
The second equation, we need to solve this one. We have 3x plus 4y is greater than 16. So Cassia, how would you get y by itself? Okay. So y is greater than? Good. So she said 4 minus 3/4 x. When do you flip the sign with inequalities?
When you divide by a negative.
Yeah, so you're dividing by a positive doesn't force the sign to flip, but if this was a -4 here, and we divided by a -4, remember your inequality symbol has to flip the direction that it was facing.
Oh, so they don't really match up.
So we have a 4, the slope is the same. Make sure it's a dashed line,
Man, I just.
Is it dash line over there, like, less than?
only a less than or a greater than. And no extra bar underneath.
Nina, if you ever put yourself down again, I might have to do too. And you were amazing. You will do that.
Okay, ladies and gentlemen, way too much talking going on. Okay, so this is what your graph should look like. Where's the solution? Where's the overlapping region?
There is one.
There isn't one. So this one has no solution. There's no region that intersects or overlaps. There's no area that's common with both colors. If my symbols were flipped, so if the top one said greater than or equal to, the bottom one said less than or equal to, then they'd shade in between. Your whole graph would be shaded because you're shading above one, below the other, but it's that overlapping region that would be in between. So if my inequalities had symbols that were flipped, then I could have a solution that would be in between.
What if there's infinitely many solutions, what would that look like?
The whole
Yeah,
thing would be
you
the
would
same color.
have to have everything like, I mean, I don't know if that would
Wait.
even be.
Would they have to be like the same line?
You have to have the same line, but you just have to shade like a one above and one below the line, but then they still wouldn't overlap.
That's so confusing.
Okay, well, I'll think that'll happen.
Yeah.
Yeah, you're killing.
All right, so
Sure.
underneath this are two more graphs. These graphs have absolute value in them, so you don't just have to have linear inequalities. If we graphed circles before we got to this, we could be graphing circles. If we happen to talk about graphing parabolas, we could be graphing parabolas. So it doesn't always have to be just lines. So since we've talked about absolute value in the last chapter, we can definitely apply an absolute value graph to an inequality. So the first one just says y is less than or equal to 3. So Katie, if it's just a y by itself in the equation, what kind of line is that? So y is less than or equal to 3. I go up to 3 on the y-axis, and then what kind of line do we make this? Right here?
That one? Oh.
Yeah.
And it's going, I'm sorry.
That's okay.
And it's going to be
Sorry.
Horizontal. So we have a horizontal line. It's a solid horizontal line because it says less than or equal to. So if the equal to is in the problem, then it's a solid line. Less than means below, so we're shading the entire region below the line.
Oh my goodness, that's a lot.
That's nice. It was a nice one. I like these.
The second one is the absolute value of x plus 4. What shape would the absolute value of x plus 4 be?
A V.
A V.
Oh, you
So
right.
remember, it's not a line if it has absolute value bars around it. This is a V, and the vertex will be at -4 because the graph is shifting left, comma 0.
Okay.
So I'm moving over to -4, putting a point, and then the slope, whatever number's in front of the absolute value bars would be the slope.
And this is nothing.
It's nothing, so there's really a 1 there. So
Yeah.
rise 1 to the right 1, or rise 1 to the left 1. That's how you get the V. So you're going up both times, but you're either going up and right or up and left to create the V. This one needs to be dashed, so make sure it's a dashed line when you connect those points.
Wait. Oh, I'm wrong.
So I moved over to 4. I moved left 4. I put a point. My slope is 1, so I went up 1, right 1, up 1, left 1.
How do you
Dashed
shade
line.
this one? In the middle of the V.
So when you shade it, remember you're thinking above or below. So if I go to my vertex, it's greater than, so we need to go above the vertex. So above means it's really in the middle of the V. Because if I'm going above all of these points, I'm in the inside of the
If
V.
it was below, then it would be everything other than the V.
Then it would be everything, everything outside of the V if it was below or less than. So the area where they're intersecting is below my y equals 3 line and inside of that V. So this actually makes a triangle.
I'm shook. I don't know how I'm gonna do this when there's so many lines. Like I really can't
Yeah.
mess it up
There's
anymore.
6
There's gonna be. I'm
You
gonna.
guys- you
I'll
should
get
give
there.
us a month
To be okay. Alright, so let's quickly graph this one here. We have y is less than or equal to x plus 2. So it moves right to -2, 0.
Billy judges me a lot.
The graph is 1/2, or the slope is 1/2. So you're going up 1, right 2. Or up 1, left 2.
My pen killed. Does anyone see a pencil anywhere? Oh, never mind.
So left 2 because of the vertex moving to the left. Slope is rise 1, run 2 in both directions, so either left or right. This one says less than or equal to. So again, back to that vertex. Less than means we need to be underneath the vertex or underneath every point on the line. The other line is just x is greater than or equal to -2. So now you're going to the x-axis of -2, which should be right at your vertex. This one is a vertical line because the slope is undefined if you just have an x. So this should be cutting your graph. That should be like the line of symmetry for that absolute value graph. This is the only time that you're allowed to think left and right with shading. So, Ethan, if it's x is greater than or equal to -2, which direction are we shading?
You said greater? I'm
Greater
gonna say right. Probably.
Yeah, so we shade to the right. So when you darken that area, you have the portion underneath the right side of the absolute value, and then you also have the portion to the right of the x equals 2. Anyone have questions?
So I was saying, mine's more brown and green. Mine's brown and green.
Alright, so one last problem. If you flip the page, there's a word problem, of course.
Of course. Okay, no. You just freaking did it, man.
So, most difficult problem part of the word problem is actually coming up with the equations to go along with it. You're selling pizzas to raise money for a school field trip. So, the pizzas are $8 and $9, cheese versus pepperoni. You need to sell at least 2 types of each pizza, and you want to sell $150. So this is every person who's going on this field trip. They each want to sell $150. So this is you, just one person. So it's not like it's for the whole school. So write and graph a system of inequalities that describes the information above. X is cheese pizza, Y is pepperoni pizzas. From the information that's given, Libby, can you come up with one inequality from the given information? How are we going to sell to create the $150? What are we selling to get that money? The pizzas. So how much does the cheese pizza cost? $8. So 8x and $9 for the pepperoni. So 9y. So my pizzas that I sell, cheese and pepperoni, has to at least be $150. It's okay if it's more, but at least $150. I also have more inequalities because right now I have one equation or one inequality which doesn't make a system. There's another sentence that talks about we have to at least sell 2 of each pizza type. How do we write that as an inequality? Katie?
When you do x plus y has to be greater than or equal to. Is that agreement?
So you're close, but my pizzas can't be mixed together. So it's not a cheese and like extra cheese and pepperoni. They're individual, they're separate.
So when you do x plus y?
So just x is greater than or equal to 2 because I have to sell 2 cheese pizzas at least. And then also y is greater than or equal to 2 because again, I have to sell 2 pepperoni pizzas. They're separate types of pizza. They have to stay separate in the problem.
Gotcha.
So at least 2 of each type would be x greater than or equal to 2, y greater than or equal to 2.
Simple.
So if we graph these first 2, go to where your x is 2, and go to where y is 2. So essentially you can't sell 0 or 1. So that still leaves us with a big area of the graph. I mean, that's still this whole area here. When we solve the other one, we'll take the 8 to the other side, so now it's -8. And divide by 9, so we have -8/9 as a slope. And 150 divided by 9, they're both divisible by 3, so that's 50/3, which is approximately 16.6.
Did you use the same color for the x greater than or equal to and the y greater than?
I did because it kind of just gives you this like region here. So instead of using both, you know that's the kind of barrier region.
Wait.
Sorry, I flipped mine. Thanks, Ethan. I just missed the inequality. So when we go to graph this last equation, it starts at 16/6, which is going to be just above 16 because we're counting by 2's. You need to count down 8, but again, you're counting by 2. So every time you go down, that's 2, 4, 6, 8. And then we need to go over 9. 2, 4, 6, 8, and then 9's going to be in the middle of a box. 2, 4, 6, 8. It's okay that it's not exactly crossing in the direct corner of a box. That one says greater than or equal to, so I need to be above that line. If I'm less than the line, I'm not selling what I need to sell to earn the 150 bucks. So it's everything above that line, but then beyond the 2 marks. So the question says, if you sell 12 pizzas, 12 cheese and 10 pepperoni pizzas, did you meet your goal? So if I find where 12 cheese and 10 pepperoni would be, is that inside the shaded region?
Yeah.
Yes. Libby.
You didn't start at the Y intersection.
I didn't start at the Y
You
intersection.
started at the,
Oh, I started there. Yeah.
No, that's fine.
6, 8, 2, 8.
Doesn't actually
It's alright. If you already have your line, it doesn't change our answer. It's still a yes.
You have a lot of them.
not that bad, I don't think.
Just makes my region a little bigger.
I like cheesecake sometimes.
Alright, so 8 graphs for your homework. 34 is just writing the inequalities. You don't have to graph. Have a good day. I'd like somebody to do 11 and someone else to do 15. Julia, would you do 11?
Wait, what was the other one?
I didn't even say mine.
15. Thanks, Cooper.
Well,
Have an excellent day.